Electronegativity is attraction for electrons. Some elements have atoms that are more electronegative than others. This determines bond type. In an ionic bond, there's a strong difference in electronegativity between the two atoms. In other words, you have one atom that has a strong pull for electrons and one atom that doesn't, and that's why they end up transferring electrons. So metals tend to give up electrons, and so they will tend to give away an electron to a nonmetal. In a covalent bond, the two atoms have similar electronegativities, and they're usually pretty strong, so that's why they share electrons. Two nonmetals will share electrons. There are two types of covalent bonds. There are polar bonds, in a polar bond, they share electrons, but it's not equal sharing. If the electronegativities or attractions for electrons are similar between the two atoms, they will share the electrons equally, and that's a nonpolar bond. So remember, these two, polar and nonpolar, those are types of covalent bonds. Okay, so sometimes we talk about this like there's three different kinds of bonds: ionic, polar, and nonpolar. But remember, polar and nonpolar are covalent. Let's look at electronegativities for a second. On the periodic table, as you move up or to the right, electronegativity increases. And there are actually numbers that are assigned to different elements. Fluorine is here. We don't normally assign electronegativities to the noble gases because they don't form a whole lot of bonds. But anyway, so fluorine is the most electronegative element. And you can see that in general, the metals have a low electronegativity, and the nonmetals up here are more electronegative. That's why when you put together a metal and a nonmetal, there's a large difference in electronegativity. The metal will just give its electrons to the nonmetal. Okay, and here's what I was saying. So nonmetals have high electronegativity, they're up and to the right, and metals have low. So these are the rules that we're going to use to determine the bond type. And we've used some of these already, but we need to get down to polar and nonpolar. So ionic, what we've learned before, that's if you have a metal and a non-metal bonding. And that will be in another lesson. We'll consider it nonpolar if both of the atoms are the same element, or if the bond is carbon to hydrogen. If the atoms are the same element, they're going to have equal pull for the electrons that they're sharing. And so it will be a nonpolar bond. They will share those electrons equally. The reason that we have this special one that we want you to know here, the C to H bond, is nonpolar, is because that is such a common bond, probably one of the most common bonds in all compounds, because it's very common in organic compounds. Most compounds are organic. So that will come up a lot, not just in this class, but when you get to organic chemistry or biochemistry, that you need to know that carbon and hydrogen form what we consider nonpolar bonds. Okay, and then polar bonds, remember, it's still both nonmetals because These are both covalent. We consider it polar if the atoms are different elements. And this is kind of an exaggeration, but we will consider them slightly polar at least if they are different elements, if the two atoms are different elements. Let's look at an example molecule and what we mean by polar bonds. So these electronegativities can be looked up on the chart. When you do sapling, you'll need to look these up either in a textbook, or I think sapling has a little chart. But anyway, so I'm pretty much telling you oxygen is more electronegative than hydrogen. And so these two electrons are literally going to spend more time with the oxygen because it's more electronegative. And same with these two. So we've got two polar bonds here, unequal sharing of electrons. If those two electrons spend more time with the oxygen, and so do these two, the oxygen's going to get a slight negative charge on it. And each of these hydrogens will have a slight positive charge.